In this video, we're going to prove that if f of x is a continuous function on a closed interval ab and the interval ab is divided into n equal partitions with delta x is equal to b minus a over n, then the difference between a right-hand Riemann sum and a left-hand Riemann sum approaches 0 as the number of subintervals n approaches infinity. We start by dividing the interval ab into n equal partitions with delta x is equal to b minus a divided by n. And so you can see on the line that we've drawn here, these are the values of x for which we evaluate the function. So x0 is a, that's your starting point. x1 is one partition away, that's a plus delta x. x2 is a plus 2 delta x. xi in general is a plus I delta x. And xn, that's just your b, that's going to be a plus n delta x. Let's actually show that. So we have xn is equal to a plus n delta x, that's equal to a plus n times b minus a divided by n. Now you can see that the n's cancel out, and if you add this, you get a plus b minus a, that gives you b. That means the last value of x is xn, which is really b. Alright, so now let's look at Rn, which is a right-hand Riemann sum. Rn is equal to f of x1 times delta x. That's basically the area of the first rectangle plus f of x2 delta x plus dot 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 plus f of xi delta x plus f of xn minus 1, the value of x before the last one, times delta x, plus f of xn delta x. So this is using the right-hand point rule. The right-hand point rule evaluates the function at the right endpoint of each interval. So now let's look at ln, which is a left-hand rule. Well, that's going to be, let's choose a different color. That's going to be the area of this rectangle. So that's f of x0 times delta x plus f of x1 delta x plus f of xi delta x plus, and the very last one, with the left-hand rule, you start at the beginning and you end one before the last. So you end at xn minus 1. That's f of xn minus 1 delta x. We're now going to subtract these. Rn, the right-hand point rule, minus ln, the left-hand rule. You can see if you subtract these are all going to cancel out. So you're going to be subtracting these. And the only thing that survives is from the right-hand point rule is f of xn delta x. And from the left-hand rule will be f of xn delta x. So that's going to be f of xn delta x minus f of x0 delta x. So now let's factor out delta x. This is a common factor, delta x times f of xn minus f of x0. Now we know that delta x, that's the width, is b minus a over n, and f of xn is just f of b, because xn is equal to b, and x0 is a, so that's f of a. Alright, so we have shown that the difference between right-hand point rule and left-hand point rule is b minus a over n times f of b minus f of a. Now let's take the limit as n goes to infinity of Rn minus ln, which is a limit as n goes to infinity b minus a over n times f of b minus f of a. Now, notice that b minus a and f of b minus f of a are fixed constants. These are constants. And in the limit, if we take the limit as n goes to infinity of b minus a over n times f of b minus f of a. This limit will be 0. So we have shown that the difference between the left-hand and right-hand Riemann sums approaches 0 as n goes to infinity. All right, thanks.